point of intersection questions are places on the SAT where we're usually going to be forced to do algebra. A lot of times we can avoid it by using arithmetize or guess and check, but a point of intersection tend to be a fairly common heavy algebra question that comes up in the SAT. Now, we can sometimes cheat a little bit. Sometimes the strategies help us because of the way they structure the answer choices, and we can use those and guess and check and work backwards. But they're doing something here that prevents us from doing that. And it's basically that they're not asking for something simple, like the value of x or the value of y, or they're not giving us points. They're giving us this kind of random thing, x times y. That has nothing to do with the question. It's just like an extra step that they make us do at the end, but it prevents us from working backwards. So they did it on purpose. So we do need to know how to solve point of intersection questions algebraically, and there are two ways to do it. Usually we can either use the elimination method or we can use substitution. And the reason that the elimination method is easier is it lets us get rid of a variable very quickly. Now the problem is that really only works when we have linear equations, because we have a simple thing. We have a column of x terms and a column of y terms, and we can get rid of one. So it doesn't work here because we have an x squared, and that's going to cause a problem. So we're kind of stuck doing substitution. But it's not so bad, right? They set up one equation for us in a way that lets us substitute easily. If they say that y is equal to x squared, then that means we can take that x squared and pop it in for any of the y's. And that's how we solve a very big problem in math, is we do not want to have two variables. If we have two variables, we can't solve. But if we have one equation with one variable, we're able to solve. And so now we have 2x squared plus 6 equals, I'm going to kind of jump ahead here and distribute, 2x plus 6. Cool. So now we can solve this. And the way to solve it is we use the fact that we have an x squared to remember that we need to get everything together. So we need to bring all the stuff onto one side of the equation so that we can factor. If there's no x squared, we bring everything away from the x. If there is an x squared, we bring everything towards the x. So let's move these pieces. So minus 2x minus 6. And one convenient thing happens here. So these all go away. That's expected. The 6's on this side also go away. But the x squared and that 2x, they can't combine. So they have to stay separate. So we still factor, though. This doesn't look like a normal factoring situation. But that's only because we normally forget the first thing that we should look for when we factor. We want to find a GCF, a greatest common factor, a number that can be divided into both of the terms. And we want the biggest number, the biggest thing possible. So obviously a 2 could be divided into both of those. But so could an x, right? Both of them have a 2, and both of them have an x. So that's my GCF. And then when we do the division, something gets left behind, right? So in the 2x squared part, an x gets left behind. So that's going to be x and then minus 1, and that's equal to 0. So that's how that's going to look factored. And so that still produces for us two values of x. Okay, so this looks a little different than what we usually think of for factoring, like question number 3 earlier in this section. But it does come up in the SAT. We do need to know how to do GCF factoring. And yeah, it's a little messier. If you're unsure, one good thing we can do if we're not confident with our GCF factoring is we can always distribute back in and think about it and say, do I get the same thing I just started with, right? So 2x times x, that's 2x squared. 2x times negative 1 would be minus 2x. So that works, and that gets us back to where we started. But instead, let's solve, right? So that means the reason we factor is it turns these into two different equations. And then for each equation, we're solving for x. So in this case, it's x is 1. And in this case, we would just divide by 2, and we'd still get x is 0. So there we go, two values of x. That makes sense because we have a parabola, and so sometimes that happens. However, they don't care about one of those values because they say that x has to be greater than 0. So the 0 doesn't count. We only care about the x is equal to 1. And then we can use that to figure out the value for y by plugging it back into either equation. And I'm going to be lazy and use the lazier equation. So y is equal to 1 squared. So y is equal to 1. And so xy is equal to 1 times 1, which is 1. So there we go. Now at the end of it, it kind of feels like maybe there was a shortcut that we could have taken, but no. And that's the problem with point of intersection questions is most of the time we're gonna just have to kind of plow through and do the algebra. And so that's why the strategy here is really show your work. Because as you can see, there are a lot of steps. There were a lot of opportunities for us to make a mistake. And we don't want to do that because if we make a mistake up here at step 1, it's going to carry through, and we're not going to know until the very end that we're wrong. And so we might have to do the question twice to fix that mistake. So the more work you put on the page, the less likely you're going to miss something. The less likely you'll lose a negative or distribute incorrectly or anything that could go wrong. So show your work, check as you go, like doing that distribution thing, and make sure that you're not doing work that's wrong because you have a wrong number. You want to be as clean as possible through these so you can get them right and so you don't waste a lot of time because they can be time consuming and that's frustrating, but I do think you want to take the time, guarantee these points. They're pretty predictable, and as far as SATs go, predictable is good.